Okay, hello everybody. This is Mr. Avant. Here I am, and I decided to come at you with a special white on blue screen. And this is going to be the last assignment before we have our Easter break. I know tomorrow is Good Friday, so I thought I'd make this a little more fun. This is actually going to be a quiz and a time to climb all put together in one special package. So here's the challenge. Not only do you have the time to climb, but you have a quiz. I would like for you to get a sheet of paper. Here's a sheet of paper. It's actually white, it's not blue. But on here is a quiz that I'm going to scan and send to you on file. And you're going to look at it, you're going to copy the problems, and you're going to try to work them out first. And then you're going to go to a time to climb, and you're going to answer your questions. And I am going to try to find, and after you answer your questions, then you're going to send your answers. You're going to try to scan this, take a picture of your work. I showed you some tricks on the previous video on how to send me completed work. And you're going to send in your work. I'm going to grade it. I'm going to see who does the best work, who's the winner of the time to climb, who turns it in, all that kind of good stuff. And I'm going to try to find a way to get you a prize or some kind of reward. The district is looking at very closely at how to do our classrooms now after April 30th in a digital way. So I'm trying to prepare you, I'm trying to get you guys ready for it. You know how I like to reward you in the classroom, to give you incentives to do your work. And now I'm going to try to go a step further. I think I can figure out where you live. I think I can drop off a prize of some sort. So, you know how it works. Let's try to do this. I called a lot of your parents. I checked in with you, and hopefully they're trying to get you online and connected. I still see that a lot of you are not on Google Classroom. You're not messaging me. You're not posting any comments. Only a couple of people are. I know Carly, Isabella, Hua, Blanca. Those are the few of the students who have actually made an effort to get on their computer and check in. Carly's been the most outspoken one, believe it or not, and she might be a big winner for this prize as well. I don't know what the prizes are yet. I'll let you know. But how do you like this blue screen? Isn't it cool? I can do all sorts of stuff. I can move around. I can look scary. I can go wah. I do stuff like that. But what I'm going to try to do now is I'm going to use my blue board with my black marker, which is actually white, and we're going to see how this works. What I'm going to do is I'm going to show you again, I'm going to review how to do these problems. These aren't the exact problems on the quiz that I have here, but they're going to work like the problems here, and I want y'all to go back to the videos, try to relearn this. If you don't know how to do it, watch how I do it on the board here, and let's see how you do. Okay, let's start off with the first thing we did. I call this Grade 4 Module 5 Lessons 20 through 34 Practice Quiz. And one of the first things we were doing on the videos is we were simply adding, this is number 1, we were simply adding two fractions together with the same denominator. But the trick is here is that the fractions get bigger on top, they become improper fractions, and you got to turn it back into a mixed number. So that's going to be the trick here. All of these answers should be in a mixed number form, meaning a whole number and a fraction. So let's try 2/5 plus 12/5. So already you can tell that the number on top is going to be bigger. Whenever you add two fractions with the same denominator, you add the top and bottom stays the same. Oh, 2 plus 12 is 14. Does that show up on white? It sure does. So 14 over 5. How do we get this back into a mixed number? We need to know how many sets of 5 are in 14, just like a division problem. This is actually a division problem. There are two ways we can do this. We can look at the multiples of 5 and figure out what do we multiply times 5 to get close to 14. Well, the multiples of 5 are 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. Well, 15 is too big. So I got to go with 2 times 5. And the 2 is the number of sets of 5 that I have. That is my whole number. So 14 over 5 equals 2 whole numbers. And what do I have left over? Well, if it's 10 over 5, if 2 equals 10 over 5, then that means I have to subtract 10 over 5 minus 14 over 5 gives me how many left over? I have 4/5 left over. So this is my answer. Or you could have did it with long division like this. I could have put a 14 here and a 5 here. Remember that the divisor is your denominator. The quotient is your whole number here. Went too far. And the remainder down here is your numerator. So let's see. Ooh, look, it just started raining. Cool. All right, so what did we say? We said 2 times 5 equals 10. I subtract, I get 4 left over. So the 4 is my numerator, the 5 is my denominator, and the 2 is my whole number in this mixed number. Let's move on to the next one. Okay, next, the second one, I want you to simply take an improper fraction and turn it into a mixed number. So we have 39 over 8, and in order to find my whole number in my mixed number, I need to figure out how many sets of 8 are in 39, and what is my remainder fraction back over 8. So we can do the multiple technique. Let's do our multiples of 8. 1 times 8 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and 8 times 5 is 35, and if I go one more, it's going to be 42. 8 times 6 is 42. That is too high. We need to use 8 times 5. So that means that 1, 2, 3, 4, 5. That means that my whole number is a 5, and I need to figure out what my remainder is. So this is saying that I have 35 eighths. 5 is equal to 35 eighths. Let me write that. 5 is equal to 35 eighths. How many more do I need to get to 39? Well, I need 4 more. Let's do that with a long division just to make sure we understand. So that is 39 divided by 8. We said 5 times 8, there's my whole number. 5 times 8 is 35. The 8 is, oh, I'm sorry. The 8 is my denominator, and the 4 is my numerator. Okay, it's just that simple, guys. You can do this. Okay, I had a shadow over that division problem. Here it is one more time. 39 divided by 8. The 5 is my whole number. The remainder of 4 is my numerator. And my divisor 8 is my denominator. Hope that wasn't confusing. Let's do the next one. Okay, this is an example for number 3 and number 4 where we're adding a mixed number to another fraction. And what's going to happen? Well, with number 3, you don't end up with an extra whole number. You simply add the fractions and it pretty much stays the same. But with this one, you're like number 4, you're going to add your fractions and you're going to end up getting an extra whole number in there. So let's work it out. So if we have 5 6/7 plus 2/7, remember, a mixed number is simply saying this is 5 whole numbers plus 6/7. So you can look at it as an addition problem like this. 5 plus 6/7 plus 2/7. Well, that is equal to 5, and the 2 and the 6 you add together and you put back over 7 and you get 8/7. But look, that 8/7 is improper. It needs to be smaller than the denominator on top. So there's a whole number in there. How many whole numbers are in 8/7? Well, remember, 7 over 7 in this case equals 1, whenever the numbers are the same top and bottom. So there's one more whole number in there. So I'll break it apart. We have 7/7 plus 1/7 equals 8/7. This becomes a 1. So it's, let me get rid of this. So that is 5 plus 1 plus 1/7, and that ends up being 6 and 1/7. That's how those problems work. They're very, very simple. If you've made it this far, you pretty much understand your mixed numbers. Now, the next few that we're going to do are going to be about subtraction. They get a little more complicated, so let's look at those next. Okay, well, number 5 is pretty simple. You have a mixed number with a fraction that is bigger than the fraction you're subtracting with. This one is smaller than this fraction, therefore all I have to do is subtract. The 2 stays the same, you just deal with the fractions. So the answer is 2. 3 minus 6 is 3/8. That's easy. Let's move on to number 6. Okay, the next one on number 6, let me make this 6 smaller so you know it's not part of the number. We're dealing with 13 and 5/15, and I'm subtracting 9/15. Now, if you remember back in the module lessons that I did, there are a couple of different ways of doing this. Let's look at the first way. Let's work it out simply by breaking apart or decomposing. So we're going to take, first we have to understand that we need a fraction big enough to subtract 9/15. Right now I can't subtract 5 and 5/15 from 9/15 because the 9 is too big. You can't take 9 away from 5. Therefore, I had to borrow from the 13. The 13, I borrow 1, so the 13 becomes 12. And I have 15/15 here, because one whole number in 15ths is 15/15. And I still have 5/15 here. I add these two together to be able to subtract 9/15 from it. So let me put an equal sign here. This becomes 12. 5 plus 15 is 20/15. And now I can subtract my 9/15 from it. 9 minus 20 is what? That is 11, believe it or not. So the 12 stays the same. Watch out, kitty cat, here I come. And 11/15, meow, meow. All right, let's look at the last one. Okay, the last one is the granddaddy of them all. This is one of the hardest mixed number problems you have in 4th grade, where you have to subtract 2 mixed numbers, and in this case, the numerator is bigger on this mixed number. So, let me explain 2 ways of doing this. The second way I do this is probably the one that works the best for me. I enjoy it more. This way is a little more tedious. It's the breaking apart method. But remember, these 2 numbers can be subtracted right away. 5 minus 12 is 7. This has to stay the same. That's 13/20. And this 5 disappears since I've already subtracted 5 away from 12. It becomes 7 13/20. But I didn't do anything with this fraction yet. It's still there, 16/20. Now it's time to break apart and borrow from the 7 to make this numerator bigger. So this 7 becomes a 6, and I borrowed 1, or again, it's going to be 20/20 in this case, plus 13/20. That equals 6 and 33/20. And now I can subtract my 16/20. All right, and 16 minus 33, I'll do it up here. Okay, I have to borrow in order to subtract 6 from 3. I borrow 1 from the tens place. That becomes a 2. And this becomes a 13. All right, 6 minus 13 is 7, and 1 minus 2 is 1. So I end up with a proper fraction of 17/20. The 6 stays the same. So the answer is 6 and 17/20. Now, I'm going to put that answer over here above the kitty cat's head, and we're going to try the next technique and see if we get the same answer. Okay, here we are on the last video, or the last segment of the video, and I'm going to take the same problem we had before. Remember, we already know that it equals 6 and 17/20 from the previous way we did it. I'm going to show you one more way of doing this if you don't remember from the other module video. What we did is we created what they called an open number line, or a blank number line that doesn't have the little hash marks. And what you want to do is also rewrite this as an addition problem. So if we do that, what we're saying is, what do we add to 5 and 16/20? What do we add to it is the answer, 6 and 17/20. But we're going to see if we get it the same way. And it's going to have to equal the bigger number here, 12 and 13/20. So we use this open number line. You draw a number line, and it usually takes 3 jumps to find out. So whatever amount you jump, that is the answer you should get here. So we're starting at 5 and 16/20, and the first jump I need to make has to get me to the whole number 6. Okay? Trying to get to 6. How many more do I need to get to 6? Well, I have to make 16/20 one whole number. I have to add 4 to 16 to get 20 over 20. So we're adding 4/20. So the first part of it is we add 4/20 to get to 6. Now we need to get way over here to 12, and then we need to figure out how much more we need to get to 12 and 13/20. Okay, so how much do we need to get from 6 to 12? Well, we have to add plus 6. 6 plus 6 equals 12. So far we have 6 and 4/20, and then we have how much more to get to 12 and 13/20? 13/20. So when I add these all together, 6 plus 4/20 plus 13/20. Let me write it over here, if you can see it. So that's 6 plus 4/20 plus 13/20 equals 6 and 17/20. It's the same answer. Bingo! There you go. Okay. So remember, I want you, of course, what I'm going to give you on your quiz is going to be different problems, but they're going to be done the same way. I want you to work them out on paper. You want to scan it or take a picture of it and send that file to Google Classroom. I know it's going to be hard for some of you, but those of you who can do it, I promise you, I do have a prize for you. I'm going to get it to you somehow. And you get it to me, and you also want to do the time to climb that goes with it. And let's have some fun and see who can answer these. I'm going to give you a lot more time on the clock for time to climb. Okay? I'm going to give you at least a minute if I can. But you want to work out your problems before you do it. They'll be the same problems that are on this sheet. So you'll have them worked out beforehand, and then you find your multiple choice answer. So even if you got it a little wrong, maybe the multiple choice answers will help guide you to the right answer. And let's see what we can do. Remember, this is what class is going to be like. So good luck, guys. Happy Easter. I love you all, and take care.